Right-cut riding lawnmowers obey the demand equation. P equals negative 1/10 x plus 1,750. Now, in this demand equation, the lowercase p stands for price and the x stands for number of units. So this is an equation that relates how many units you sell to the price of the item you sell. The cost of producing X lawnmowers is given by the function C of X equals 110x plus 7,000. We have multiple parts here, and some of these parts are going to involve some business formulas. We want to express the revenue, R, as a function of X. And we're going to use this business formula. Revenue is X times P. This is the same X and P that we used in the demand equation a moment ago. Remember that X is the number of units and the lowercase p is the price. In part B, we want to express the profit, capital P, as a function of X. And we're going to use another business formula. Profit, capital P, is found by using the revenue minus the cost. So we've got a lowercase p for price and an uppercase P for profit. And then we have a few questions. What is the revenue if 8,200 units are sold? What is the profit if 8,200 units are sold? And what price should be charged if 8,200 units are sold? Okay, let's start off with part A. In part A, we want to find the revenue using the formula X times P. So remember I told you that X is the number of units, the lowercase p is price, and we're going to use the demand equation to write the revenue function as a function of X being the only variable. Right now we have two variables, X and P. When we make the substitution, we will only have the variable X. We're going to do X times negative 1/10 X plus 1,750. We'll use the distributive property, distributing this X, and that will give negative 1/10 X squared plus 1,750X. So we have our revenue equation. From there, I can find the profit equation. Profit is revenue minus cost. We just found the revenue in part A, so we'll use negative 1/10 X squared plus 1,750X. And we want to subtract the cost. The cost was given right here. And I want to subtract the whole cost function. So I'm going to put parentheses. So that minus applies to every term. Minus 110x plus 7,000. We'll distribute that minus to both terms to get negative 1/10 x squared plus 1,750x minus 110x minus 7,000. We have some like terms to combine, two terms with x in it. So that will give negative 1/10 x squared plus 1,640x minus 7,000. So we have our profit function. Now we're ready to answer these questions. In part C, what is the revenue if 8,200 units are sold? Remember that X is the number of units, so 8,200 is what we substitute in for X, and we're going to do it in the revenue function. So revenue at 8,200 will be negative 1/10 times 8,200 squared plus 1,750 times 8,200. So let me grab my calculator to help me with this calculation. All right, we've got -1/10, 8,200 squared plus 1,750 times 8,200. So this gives us a revenue of 7,626,000. 7,626,000. So that is our revenue when 8,200 units are sold. In the next part, we want to find what is the profit if 8,200 units are sold. So once again, the 8,200 is our X, and we're going to substitute into the profit function that we found here. Substitute an X of 8,200. So in part D, we're finding the profit at 8,200. That's -1/10 times 8,200 squared plus 1,640 times 8,200 minus 7,000. So let's get our calculator out for this. So we've got a -1/10 times 8,200 squared plus 1,640 times 8,200 minus 7,000. So we've got a profit of 6,717,000. Okay, our final part, part E, is what price should we charge if 8,200 units are sold? For that, we'll use our demand equation. The demand equation, P equals -1/10 X plus 1,750. So -1/10 times 8,200 plus 1,750. Let's grab my calculator again. We're at -1/10 times 8,200. And this is a 50, not a 70. So then plus 1,750. So we should set the price for the riding lawnmower at $930. Thank you for checking out my videos. Have a great day.